Okay, so let me give you write down the exact mean value theorem, what it means, okay? So let f be a function such that, so one, f is continuous on interval AB, and two, f is differentiable on AB open. Okay, so it's the exact same thing as Roll's theorem, except that we don't have the condition that f of A equals f of B. Okay, then there is a number C in interval AB such that f prime of C is equal to f of B minus f of A over B minus A. So we need a picture to illustrate this. Okay, let's see what does the theorem tells me. A, B. Okay, this will be, of course, f of A and f of B. And like this, I have a function f. So what does the theorem tell me? Is that the slope of this line okay, is of course f of B minus f of A over B minus A, right? y2 minus y1 over x2 minus x1. Well, the theorem tells me that there is definitely a value C where the tangent line is parallel to that. C. And this here, of course, the slope is f prime of C. Do you understand? That's what it means here. there exists a C such that the derivative at C, in other words, the slope of the tangent at x equals C, is equal to the average slope, okay? In other words, the slope from beginning to end. What was that noise? Was that from me? No, I guess not. Okay, questions?
What scenario would we use this?
What, sorry, what?
What scenario would we use this theorem?
Okay, it's a good question. So where do you see this? So a good example where you could see this is, let's say you're driving a car, okay, and you're at a certain, you're leaving home now, and you're driving, accelerating, decelerating, braking, stopping, whatever, and you get to a place, okay? So if of course, given that you accelerate and decelerate in a smooth manner, okay, so there's no discontinuity, well, if you calculate your average speed, okay, which is the slope of this line, there's for sure a time in your route where your speed was exactly equal to the average speed.
Okay.
Okay, that's what it means. Maybe you're going to slow down, accelerate, but at some point your speed will be exactly the speed of the average speed.
Okay.
Okay. Okay, let's do an example before we prove it. Okay, so we have to prove this theorem, but before that, I want to do an example with a function. And let's see how this works. Okay, any questions? Anybody? Okay, it has to be clear. I'm going slowly because it's important. It's theorems, and theorems are very fundamental.
So this theorem, all that is saying, it's that at point C, the derivation of the point C, the tangent is equal to the tangent to the normal displacement.
You didn't. It's not formulated the way I want. Okay. So first of all, this is not a tangent. Okay. Mm-hmm. What I'm saying is that if the function is smooth, okay, means continuous and differentiable, so nice and smooth.
Okay.
Well, guaranteed, okay, between A and B, guaranteed that there is a value C, there exists a value between A and B where the tangent is parallel to the to this line here, which represents in our case the average slope.
Okay.
Okay. Mm-hmm. With the average rate of change. Okay, so here's an example. Let f of x is equal to x cubed minus x on interval 0, 2. So find the value or values, it could be more than one, that satisfy the mean value theorem. Okay, so this is mean value theorem. Okay, so let's solve this. So f prime of x, okay, so I'm going to need the derivative, is 3x2 minus 1. Then I'm going to need f of 0 and f of 2. Okay, so f of 0 is 0, and f of 2 is 8 minus 2 is 6. Okay, any questions? Okay, so let's see if there exists such a C. We need to find the C. So f prime of C has to equal to f of B minus f of A over B minus A. In our case, 3C2 minus 1 has to equal to f of 2, which is 6, minus f of 0, which is 0, over B minus A, which is 2 minus 0. Okay, and so this means that 3C2 minus 1 equals to 3, 3C2 equals to 4, C2 equals to 4/3, and so C is equal to plus or minus the square root of 4 over square root of 3, and so C is equal to plus 2 over root 3, or C is minus 2 over root 3. These are the two values. Oops, I have to move up a bit, sorry. Okay, so these are the two values where the slope is equal to 3, which is the average slope. Okay, let me just draw. It would be good to draw. Okay, so I have 0, 0, 2, and 6. Okay, so I don't know what my function looks like. Let's say it looks like this. Okay, and this is 0.26, and this is my average rate of change. Oops, sorry. Okay, so somewhere, I don't know where, somewhere here, there is a tangent. Okay, apparently that is exactly parallel to the average. So that's what the theorem tells me. So 2 over root 3. Okay, so of course, this value I need to reject because it does not fall in my 0 to interval. Okay, it's negative, it's before 0, that doesn't include. Okay, so this is my value, 2 over root 3. And that was the question. Find the value that satisfies the mean value theorem. Well, it's 2 over root 3. At 2 over root 3, the slope of this tangent will be exactly equal to 3, just like here. Is this clear? Okay, that's it. That's the mean value theorem. The only thing we need now is to prove. And I want to make sure that this is 100% clear before. What if, I have a question, what if A equals to B? If A equals to B, that means that the function is completely closed. I don't understand. I think you mean what if f of A equals f of B? I mean, whoever asked this question. Whatever. Okay, let's go. Let's move on. Sorry, somebody's chatting the question, but I don't get your question. Either speak or write more words so that I could understand. Okay. Okay, let's go. Let's move on. Let's prove it. So proof. So what's given to me? F continuous on AB, F differentiable on AB. So I want to know, does this imply, question mark, I don't know, does this imply, just having with these conditions, could I say that there exists, so this is the symbol for there exists, you know the symbol? Have you seen this before? Okay, so you're learning something new today again. Okay, it's good that you get used to the mathematical symbols. You're going to probably see them a lot. So this means there exists a value C sorry, such that,
Love you.
thank you, such that f prime of C is equal to f of B minus f of A over B minus A. Okay, so I'm assuming, because I got a question in the chat, I said the question was, what if B equals to A? And then I asked, what does that mean? He wrote B minus A. So I'm guessing that if B equals to A, then B minus A is 0 and it doesn't work. Is that your question? I'm not sure. Okay, well, if B equals to A, let me go back to the picture. Okay, if B equals to A, it's good that you ask yourself these questions. Always look at the limit cases. Well, if B equals to A, then we don't really have an interval. And so we really don't have a function, we just have a point. And if there's a point, then there's no question of differentiability and there's no question of continuity either. It's just a point. Okay, so we're looking for a real interval. Okay, so let's prove this. So here it goes. So I'm going to create a very weird function now, okay, which I'm going to call g of x, and I'm going to write it as follows. G of x is equal to f of x minus f of a minus f of b minus f of a over b minus 8 times x minus 8. This is a function that I'm creating. Okay, so of course you could ask yourself, where did I come up with this? It's a very valid question. Okay, how did I create such a function? Well, I'm going to explain to you where it comes from. Okay, let's just work with this first, with this function, and get to the proof, and then I'm going to explain which from. Okay, first, let's see what g of a is. G of a equals what? Okay, so if I replace every x by a, what do I get? I'm going to get f of a minus f of a minus f of b minus f of a over b minus a times a minus a. So this is 0, this is 0, everything is 0. Okay, good. So g of a, for this function, g of a is 0. Let's calculate g of b now. So g of b will be, so f of b minus f of a minus f of b minus f of a over b minus a times x is b, so this is also b minus a. Okay, so this here will cancel, and you will have fb minus f of b minus f of a minus f of b minus f of a, and so we'll get 0 again. Any questions? Okay, I'm waiting 2 seconds for you guys to get the information so that it sinks in. Okay. Good, no question? Anybody want me to slow down? All right. It's good news. Either you really understand or you're asleep. I hope you understand. Okay. And if you sleep, I hope you're sleeping well. So let me move on. Okay, so I just created a function g for which g of a is 0, g of b is 0. Let me check now if g is continuous. So first, g of x, well, is continuous on AB. So that's not a problem because g is just, it's a continuous function added with a continuous function. There's no, everything's continuous here. Okay, there's no problem. X is not under the square root, is not on the denominator, there's no problem. Okay, same thing, g is differentiable. On AB, no problem there. Okay, because the derivative of f exists, because in the hypothesis we said that f is differentiable. And this is a number times x, that's no problem. You could derive this. So what do we have? I have a function that is continuous, differentiable over an interval, and g of a is equal to g of b. So we could use Rolle's theorem now. Okay, so we can use, okay, so here this means that from here I know that g of a equals to g of b. Okay, so we can use Rolle's theorem. Okay, and therefore there exists C in interval AB such that what? What does Rolle's theorem tell me?
There's a derivative of C on that interval that's equal to 0.
Perfect. G prime of C is equal to 0. Okay, so there's definitely, we know for sure, since the function g that I created, I did it in a way that it is continuous, differentiable, and g of a equals g of b, then guaranteed that there is a c in that interval for which g prime is 0. Okay, this, I didn't invent anything, I just created a function that satisfies rho theorem. In other words, I just made it so that g of a equals g of b, bottom line. Okay? And so what does that mean? So what's g of x? What's g prime of x? So I have to find the derivative of this. Okay, so g prime of x is the derivative of this big function. So I'm going to do in steps. So f of x minus f of a minus, and I'm going to distribute this inside. F of b minus f of a over b minus a times x, and then this times minus a. So plus f of b minus f of a over b minus a times a. That's what g of x is. So I'm looking for this prime. Yes, with me? Okay. So I have the derivative of a sum, 1, 2, 3, 4 terms. This is constant, so it disappears. This is constant, so it disappears. So it's just the derivative of this, which is f prime of x. And the derivative of this term, well, it's a number times x, so it's just going to be the number. So minus f of b minus f of a over b minus a. This is what g prime of x is. Is that okay?
Sir, what happened to f of a?
F of a, this one here?
Mm-hmm.
Well, that's a number, right?
Oh,
And
okay.
if you derive the number, you get 0.
Okay, thank you.
Okay. Okay, I'm waiting for your questions. If you want me to slow down and wait 2 seconds, I could do that too. Okay, nothing? All right. So g prime of c equals 0, guaranteed. So that means that this, with if x is c, has to be 0. So g prime of c equals 0 implies that f prime of c minus f of b minus f of a over b minus a is 0. And therefore, if I send this term on the right, I will get f prime of c equals f of b minus f of a over b minus a, and that completes the proof. That's what I wanted to show, that there exists a c for which f prime of c equals to that. Is there any question? Other than, of course, where did I come up with the g function, with the weird function, okay, which I'm going to try to explain to you right now.
Can you repeat the last step?
The last step, which one, right here?
Yeah.
Or before that?
No, the last one.
The last one, I just sent this term to the right. That's it. This fraction I sent to the right, the minus became a plus, and here, it's here. Yeah?
I also got a question.
Sure.
At the beginning, when you get g of a and g of b, and both of those are equal to 0, why is that? Why are they equal to 0?
Why are they equal to 0? 1 second.
Yeah.
Okay, because, check, if I plug in a, so let's see g of a first of all. So if I plug in a here, let's just move up a bit lower so you can see. Okay, so if I plug in a here and a here, here they are, a and a. So f of a minus f of a, that's out. And then a minus a, that's 0 also. So 0 times all this is 0. This is 0, this is 0, I get 0. You see?
Okay, yeah.
Same here. These ones will cancel. and you have f of b minus f of a minus f of b minus f of a. This cancels.
Okay, okay, I got it.
Okay, good.
Thank you.
It's a very clever proof. Okay. Let me show you just, you don't need to, but it's good so that you maybe one day, if you ever go into mathematics, you'll know the reflexes that you need to have. But if you don't, of course, you won't need to do what I'm showing you now. But where does this g of x come from? Okay, so it's from here. Okay, so this is point A, f of A, and this is point here, B, f of B. This is my function f. Okay, and this here, so at a certain value x, this distance is what I call g of x. Okay, so that's what I did. That's how I found g of x. I did f of x minus the y of this function. Okay, so if you find the equation of this line, okay, you will see that it's y is equal to ax plus b. And that's going to be exactly equal to the expression that you have up there. Okay, so it would be, let me just, 1 second, erase here. I'm going to bring the f of x right here so you could see better. F of x. Okay, so it's really f of x minus y, and this expression here is exactly this. If you find the equation of the line, it's going to give you this. Okay, y equals ax plus b, but I just wrote it in a different form. I could have changed the form, but it's the same thing. Okay, so as you see at a, right, the distance here is 0. And at b, the distance also is 0. That's why g of a and g of b are 0. Because, right, that's g. 0, 0. Good? You see it? That's pretty much it for the proof. Any questions? Okay. We're done the theorems. Okay, let me just summarize everything. Could I take this out? Anybody still writing? Okay, good. I see the 4 people whose faces I see that you're done. Good. So I'm assuming the rest also. So let's go. So let's do a little summary. So I'm going to write down the 5 theorem that we wrote. Okay, so first of all, the extreme value theorem. What does it say? Is that if f continuous on AB, then f reaches a maximum and a minimum value. It reaches its max and its min. Okay, so maybe I should put a little picture next to it. It always helps. All right, so the only requirement here is that the function be continuous. It doesn't need to be differentiable. Okay, so it's important to know why you don't need, it doesn't need to be differentiable here. Okay, so it's that will show me that you understand. So here's the idea A. So I'm going to show you a function that's not differentiable, but still reaches its maximum. So here's a case, up, up, up. Okay. So as you see, it reaches a max and a min, even though it's not differentiable here. Okay, so max, min. This is the extreme value theorem, but it has to be continuous. If it's not continuous, we talked about this already, I could have cases where it doesn't reach a maximum. Okay, for example, if there's an infinite discontinuity or a jump or removable discontinuity somewhere. Then Fermat's theorem. It says that if f is continuous on AB, and now f is differentiable also, okay? So it says that if f has a maximum or minimum at C, then f prime of C is equal to 0. Okay, so this is Fermat's theorem. Max, min, okay. So now it says that here and here, the slopes are 0. Okay, this is what Fermat's theorem tells you, as long as it's differentiable. Good? It's good to see a summary. Next theorem is the intermediate value theorem. So f continuous on AB. Okay, then we said let n be any number between f of A and f of B. Okay, of course, f of A different than f of B. Then there exists a C, a C in AB such that f of C equals n. Okay, so any value n between f of a and f of b comes from, is the image of a value c that comes from the interval ab. This is the intermediate value theorem. Rolle's theorem. So f continuous on AB, f differentiable on AB, and f of A equals f of B, then there exists a C in interval AB. So this we just did, such that what? Remember by heart? Forgot?
So that at point C the derivative is 0.
Is what?
At point C that the derivative is 0.
Very nice. Such that f prime of C is 0. Very good. Okay, let's draw it here. Space to do the mean value theorem. Last one. A, B, of course, they're at the same level, A and B. So what it says is that the function guaranteed that there is a value C where f of C equals 0. F prime of C equals 0. Guaranteed. Okay, last one. It's the mean value theorem. So again, f continuous on AB, f differentiable on AB, then there exists a C in AB such that, and that's what we just proved a few minutes ago, f prime of C is the average rate of change, f of B minus f of A over B minus A. These are all the theorems. We only proved 3 of them. Right, 1, 2, oh, not even, we just proved 2 of them. Yeah, because the rest, we don't have the tools for it. Okay, so this was this one here. it.